Now that we've reviewed last class, the last like 2 or 3 classes work, it's time to move on to today. Today we're going to be evaluating using function notation, which you've done before, and we're also going to be determining the domain and range of these functions. And some of them will be relations, and that'll just mean that x repeated. For function notation, reviewing it, you're used to seeing y equals something with x plus something else. You're used to seeing y equals. Y equals is easy to understand because it's less letters. But now we're calling it function notation, and all that means is instead of writing y, we're changing y to f of x. Just because it's more specific. This way we can put multiple lines on one graph without thinking they're all the same line. If all you put was y's, then you wouldn't be able to tell one y from the other y. F of x is the same thing, so we could write this as f of x equals 2x plus 1. Please write down what I have written, and don't let it scare you. Y equals is the same thing as writing g of x. G of x is the same thing, it's just a different notation that's more specific. Don't let it scare you. You don't have to write the don't let it scare you part down, but write down what I have above, including this. Even if it's an h of x is the same thing as y equals 2x plus 1. I told you last week, open your mind, change your views. Now let's review evaluating using function notation. Evaluating means we're actually going to plug something in. Here's our function. And when we write f of negative 2, this means plug in negative 2 for x. If a number is in the parentheses, simply plug it in for x. That means we're going to do 3 times negative 2 plus 2, which equals negative 6 plus 2, which equals negative 4. So what we put for x was negative 2, and what we got for y, because remember, y is the same thing as f of x, y was equal to negative 4. That's why we had to come back today and make that connection all of these times. If you're plugging in something for a function, you're finding the y for that function. Now let's graph this. X, y, put those arrows on the end. We need to go 2 to the left and down 4. You don't need to draw the grids, you only need to put the tick marks. This was f of negative 2. Now let's find f of negative 3. That means 3 times negative 3 plus 2, which is negative 9 plus 2, and then those two add together to make negative 7. The x is what was in the parentheses. The y is the final answer. Y equals negative 7. Now let's graph this. We need to go 1 more to the left and 3 more down. Here's our new point. I'll use a different color for that one. That's f of negative 3. Let's do f of 1. 3 times 1 plus 2. 3 plus 2. 5. X was 1. Y was equal to 5 in the end. In today's lesson, you can connect these dots with a line, and you would call that line f of x. In tomorrow's lesson, we'll talk about how not everything should be connected with a line. Some things can stay just dots, but this is something that can be connected with a line. I want you to try these next ones on your own. Plug in the number into the correct function. I'll show you the answers in about 5 seconds. So pause the video before you get all the answers. Check your work. Notice that I wrote down the ordered pairs because every function is associated with some graph. I'm not going to say line this time because, like I just said, not all of them are lines. Some of them can just be dots. It just depends on the situation. Notice, negative 2 squared is negative 2 times negative 2. A negative times a negative makes a positive number 4. This is part of your practice for today. I need you to do these 6 questions and turn them in. In this situation of function notation, instead of just plugging in one number, we're going to plug in all of this. I did notice in a few days ago's work that not everybody understood it, but it is exactly the same. All you're going to do is replace x with x plus 3, which means anywhere you see x, which is just right there, instead of writing that, you're going to put x plus 3. F of x plus 3, because we saw an x over there too, is equal to 2 times x plus 3 plus 6. Now we're going to distribute to get 2x plus 6 plus 6, which is 2x plus 12. F of x plus 3. When we plugged in x plus 3 for x, our answer was 2x plus 12. This equals 20 does mean something, and we'll talk about that in just a couple minutes of the video. I'll do one of these with you, and the others I want you to do on your own. So I will do number 3. We are going to put this for x. Instead of writing x, we're going to write x minus 10. That means 1/2 times x minus 10, because I just copied that down here, and then plus 6. So I need to distribute. This 1/2 is multiplying x, and the 1/2 is multiplying negative 10. 1/2 times 10 plus 6. 1/2 of x stays like that because it's a variable. 1/2 of 10 is negative 5 plus 6 leaves 1/2 of x plus 1 is h of x minus 10. Do 1, 2, and 4 on the page that you're going to turn in. If you're doing this inside of your notes, then make sure that you point out which ones I need to grade whenever I look over your work.